Hello, my name is Pika Folfak, and I'm presenting my solution for the AWS Aurora challenge. My solution is for best Aurora MySQL. What problem am I trying to solve? Well, if you ever try to buy or sell a stock of a company who's going through a major crisis, you've probably experienced a situation where the system through which you are buying or selling the stock tells you either to try again later or wait. This probably happened because they are experiencing more than usual amount of transaction. Now, this issue is even worse when you're trying to buy or sell digital currency. But most of the time, the system provider do not try to solve the problem just because the cost of solving the problem is far bigger than the benefit. In fact, to solve the problem, they will have to figure it out and allocate upfront certain amount of resources to deal with the time when they are experiencing more than usual number of transactions. And not only they have to do that, they will also have to suffer the cost of the extra resources when the system goes back to normal. Now, if there was an option where they would just buy what they need when they need it, this will probably be optimal for them and they will solve the problem. My understanding is that AWS Aurora is just that. So we are going to be building a mobile app to allow users to buy and sell stock and digital currency. The app name is called Xschange, and like I said earlier, this submission is for the option Best Aurora MySQL. Here is a look of how our architectural diagram looks like. We have a mobile app that is retrieving data, which in this case is going to be stock data and digital currency data from an online API. In this case, we are using an API called IEX that provide real-time update of stock data and digital currency data. Also user. Now, we are communicating with AWS, and most of our requests, actually all our requests, go to AWS through API Gateway. API Gateway then forward our request to a Lambda function that execute what is it that we're trying to achieve. Then Lambda, through the VPC Gateway, submit our request to Amazon Aurora. These are the list of components of our application. We have a mobile app that's built using the Ionic framework, Angular and Apache Cordova. Now our backend is made of, like I said earlier, Lambda function. The Lambda function I built with Node.js, and our artifacts are pushed to AWS using the serverless framework. This is our very small SQL diagram. We have a table that stores user data. This is needed for both login and registration. We have a table cell that stores transaction data. Here we are referring to buying or selling stock or digital currency. We also have additional table needed for all the configuration of the sales table. Let's get to the demo, the fun part. When the app loads, you either have to sign in, sign up, or continue as a guest. I am going to register by providing an email. Let's use test.real@me.com. Actually, test.real at test.com, for instance, and use the first name as test and last name as real. And we're going to use a password test real. We're going to tap the passwords again. This here, and we're going to create an account. It says account was created. Please sign in. Let's use that to sign in. It was a test that real at test.com. The password was test that or test real, I believe. Test real, and we are in. We have a stock tab that shows us stock information for a major company. These are preloaded, but in the ideal case, we wanted to have a search here where the user can search for a company and display stock. But we just focus on having all these companies loaded. We also have a crypto tab that gives us some information about cryptocurrency, and we have the wallet tab. In this case, the wallet is empty, which is this supposed to show you all the different transactions that all the stock and cryptocurrency that the user has. Now here in the stock tab, we can see the value of the stock, and we can add a stock to a cart by tapping the cart. Now the favorite, the star, is not currently implemented because it is meant to mark a company as favorite or a cryptocurrency as favorite. That way it always shows on the dashboard. So I see as we add the cart, keep incrementing, we're adding stuff to cart so we can actually purchase a stock. We can also add a cryptocurrency or a currency to a cart or a cart. It's going to do the same thing, but here you have to specify how much you like to buy. So I'm just going to say maybe 53, for instance, dollars of Bitcoin Cash. I'm going to add that to a cart. I can add more if I want to. I'm just going to stop there for now. And then my wallet is empty, and now I'm going to check out. And I'm going to do that by just clicking on the cart icon, and it brings me to the cart. Here I can increase the amount of share for companies, or the amount of stock. I can increase or I can decrease, and I can also like I said, I can also decrease. Now I cannot increase how much cryptocurrency I have. Not to do that, I have to go back and add the value of a cryptocurrency. I'm just gonna simulate checkout. Just ignore that, it's currently implemented. And I'm just gonna check out. I'm gonna go check out and say succeeded. Now this is showing that the wallet tab has like something. This is a bug. So I'm just gonna click on it again, and then it shows us that we have like 2 shares of Google, which value at $2,000, 3 shares of Microsoft, $318, and then it says 1 share of Bitcoin Cash, but it's really not 1 share. It's just saying that we have $53 worth of Bitcoin Cash. Now I can decide to add more, or I can add more. I'm just going to add some Tesla and Facebook stock. I'm just going to add more of these. And again, if I go back to here, like I said, this is showing as the wallet tab is showing as a cryptocurrency, as a stock, but it's really not stock. It's a bug. Now at the bottom you see like the amount of portfolio. But these actually transactions are being saved into the Aurora database. So this save and retrieve from Aurora database. When I make a purchase, it saves it to Aurora database, and then this wallet tab retrieves it from there. I can sell it. I can decide to sell some stock from Facebook. You see the sell icon shows up. I'm gonna sell like some of the Bitcoin Cash. Now again, it tells me how much I want to sell. I'm just gonna say 78. Right now, you can sell more than you own, more than you have, which is not valid. Again, it's something that we haven't worked on it yet. Like I'm selling 78 when I actually have less than that. So I'm just gonna add it to the cart, and then I can actually check out, selling this. And again, this is saving to the Aurora database. Like you see right now, this is showing that the wallet is showing like the stock. This is a bug. So just tap it again, and then it will show you what is there. And so this is pretty much what the app is doing. This is just buying and selling, through this app, and we are saving the transaction to the database. And the idea being that if when there is a huge amount of transaction, we don't want our user to suffer from that. We want to be able to take advantage of Aurora and just handle as many transactions as you can. I just wanted to quickly show you my backend code. This is the Lambda function that are responsible for accepting the request from the mobile app. And this is my YAML file. Most important, this is what is used for the serverless framework. As you can see here, these are the functions that are being used to make requests to the backend. And the serverless framework uses file to auto-generate all the endpoint and make it available through API gateway. Here, I try to automate the creation of my cluster and DB instances through this, but I need to. This is for continuous integration. I need to finish this part. If there is a need to connect to my cluster, I'm making this available. These are the connection information to connect to my cluster. I use my SQL workbench to connect to my cluster. This can also be done through command line. Let's also take a quick look to my cluster in my AWS console. So here you can see that I have a one cluster, Hackathon cluster. It's on Aurora MySQL, and inside of it I have two instances, one of them being master and the other one being replica. I'm just going to take a look at here at the cluster and show you the replica policy. I created one replica policy. Auto scaling policy. Here you can see that I say that I have an auto scaling policy to replicate so to keep an average connection of 5. Just want to show that